Namaste. I, Jv'n Swarnima, Assistant Professor in Jayoti Vidyapeeth Women's University, Faculty of Education and Methodology, Department of Science and Technology. In this session, we will discuss about the introduction of engineering mechanics. So, firstly, what is science? We talk about the most of this thing is related to the science in the present world. So, what is science? Uh, if we defined it as the growth of ideas through observation and experiments, that is science. Okay, so if we or differentiate the science word, because the world of science is vast, the world of science is very vast. Okay, so if we make a word which is applied science, so what is applied science? The branch of science, it is the branch of science, just because of the world of science is very vast, so it is a branch of science which coordinate the research work, for practical utility and service of mankind, that is known as applied science. So science which defines the growth of ideas through observation and experiments. In the science, there are a branch which is we known as a applied science. Which what is applied science? A branch which coordinate the research work for particular utility and the service of mankind. Okay, so now let's move to the mechanics. What is engineering mechanics now? It is also a branch of science. Okay, like there are vast world of science. Okay, there are so many branches of science. The one branch is applied science, as we talked, and another branch is engineering mechanics. So what is engineering mechanics? Engineering mechanics is that branch of science which deals with the behavior of body when the body is rest or when the body is motion. Okay, so that is known as engineering mechanics. In the engineering mechanics, we will study on a body which either moved or rest. Okay, so engineering mechanics may divide it into statics and dynamics. Okay, so the branch of science which deals with the study of body when the body is at rest, that is known as statics. As the word statics, that means at rest. So when we deals with the study of the body which when the body is at rest, that is known as statics. Okay, and while the branch is of science which deals with the study of body when the body is in motion is known as dynamic. Okay, clear? First, engineering mechanics. First, science branch, engineering mechanics branch divided into two parts, which is statics and dynamics. Statics, which when the body is at rest, dynamics when the body is moving. Done? Now, dynamics further divided into two parts, which is kinematics and kinetics. What is kinematics and what is kinetics? The study of body in motion when the force which cause the motion are not considered. That is kinematics. In the body, when the motion is when body is in motion, but the force which causes that motion is not considered, is known as kinematics. Okay, and when the force is considered, that is kinetics. Okay, so first thing is science. In under a science, the branch is engineering mechanics. Then it further divided into two parts. First is statics, second is dynamics. Dynamics branch is further divided into two parts. First is kinematics and second is kinetics. Then now, there are some definition which are the basic of engineering mechanics. Let's talk about them. Vector quantity. First thing is vector quantities. What is vector quantity? A vector quantity is when a quantity which is completely specified by magnitude and the direction, like velocity, like acceleration, like force, like momentum. Okay, so when a quantity, if I am talking about a quantity which have some magnitude and any direction, that is known as my vector quantity. Then So, what is scalar quantity now? A scalar quantity is completely specified by only and only and only by magnitude. There are no direction. We don't talk about any direction in this scalar quantity. This is the main difference between the vector quantity and the scalar quantity. What is the difference? In the vector quantity, we will talk about the magnitude and direction both, but in the scalar quantity we will talk about only and only and only about magnitude. Then, so for example, mass, length, time, and temperature, we will not say like in this direction the temperature is this, in this direction the time is this. We can say the time in that city, or we can say the time in that place is different, but we cannot say in this direction, or in north direction, or in south direction my time is this, my length is this, my mass is this. No, we can only say my time is this, my time is x, my my temperature is y, my mass is z. But in the vector quantity we can say in the north direction my velocity is x, in the south direction my car is moving, my car is moving, the acceleration of that car is y in the south direction. So that is my differentiation between the quantities, which is vector and scalar. So the next is particle. A particle is a body infinitely small volume, which is negligible, almost negligible in dimension, and the mass of particle considered to be concentrated at a point. So that is known as my particle. Next are a law which is more important, most important, which is the law of parallelogram force. What is law of parallelogram force? The law of parallelogram force is used to determine the resultant of two acting at a point in a plane. Okay, if a point, if I have a point and there are two forces are acting on that point, then I have to determine the resultant. Like if one force is acting on this direction and one force is acting on this direction, then what is the resultant? We can find out. Okay, if my force is in this direction and the other force is also this direction, then we have to determine. So there is a law of parallelogram of force, which we by which we can determine the resultant of two forces acting on a point on in a plane, same plane. Okay, so it states if two forces acting at a point be represented in a magnitude and direction by the two adjacent sides of parallelogram, then their resultant is represented in magnitude and direction by diagonal of parallelogram passing that point. So let's more understand it by this diagram. If my force, if my one force is acting on this point, and the other force is acting on this acting on this direction, and one force is acting on this direction by this point, then my resultant force will be what? My resultant force is their two adjacent sides. Then sorry, then my resultant force is represented by the magnitude and the direction, magnitude and the direction of diagonal of parallelogram passing through that point, passing through that point. So this one is my resultant. If my one force is q, the second force is p, then my resultant force will be this one. Okay, so let's calculate about the magnitude of resultant force. So from C, draw CD perpendicular to OA produced. From C, we draw a CD perpendicular to a OA force. Okay, OA, sorry. Then the angle between these are alpha, between two forces, which is P and Q, is alpha. Uh, Angle DAC equals to angle AOB, which is angle DAC is equals to angle D O and B. Okay, so this will sorry, angle DAC is equals to angle DO and B. So both are alpha. Okay. In parallelogram, OACB is AC is perpendicular parallel to Q, parallel and equal to OB. So A and C is equal to O and B and also parallel. So AC will be Q. Then in triangle ACD, in triangle ACD, AD equals to AC cos alpha equals to Q cos alpha. CD equals to AC sin alpha, which is Q sin alpha. Why this AD equals to AC cos alpha and why this CD equals to AC sin alpha? By sin alpha formula and by cos alpha formula, which says cos alpha equals to what? AD AD divided by AC. So my cos alpha, my AD will be AC multiplied by cos alpha. And what is sin alpha? My CD divided by this AC. Okay, so my sin alpha will be sorry, CD will be AC multiplied by sin alpha, and the value of AC is Q. We already defined it here. In triangle OCD, OC square equals to OD square plus DC square. What is OC? OC OC is R. Okay, and OD, what is OD? OD is OA plus AD. Then, so what is OA? That is P. What is AD? Which is Q cos alpha. Put these DC equals to Q sin alpha. Put these values in the equation, that which says R square equals to P plus Q cos alpha plus Q sin alpha square, which is uh, resultant force equals to result square of resultant force equals to both forces squares, addition of both forces squares, which is R square equals to uh, this OD square plus this DC square. Then, so if we solve it, then R square P square plus Q square cos square alpha plus 2PQ cos alpha. Why? Because A plus B square formula is A square plus B square plus 2AB. So P square plus Q square in multiply by cos square alpha plus 2PQ cos alpha, and by this plus Q square sin square alpha. So after solving it, my value will be P square plus Q square plus 2PQ cos alpha. And when we have to find out the R value, so we can remove this square by taking under root of this side. So P square plus Q square plus 2PQ cos alpha, which is our first equation, which is our magnitude of resultant force, which we can say the formula of resultant force. Okay, so now decide the direction of resultant force, because it is also important, because it is a vector quantity. We have to find out the force direction and force magnitude also. So we already defined the magnitude. Now we calculate the direction. So theta will be angle made by resultant with OA. Then from triangle OCD, tan theta equals to CD upon OD. The value of CD is Q sin alpha. The value of OD is P plus Q sin alpha cos alpha. Then theta will be tan inverse bracket में Q sin alpha plus Q cos alpha. P plus Q cos alpha. This is my magnitude. Now, there are two cases are important in this phenomena. The first, if case is if two forces P and Q act at a right angle, that means act at a right angle. That means my alpha will be 90 degree. Then from equation 1, my resultant of my magnitude of my resultant will be R equals to P square plus Q square plus 2PQ cos alpha. Then put this alpha value with 90 degree. Then cos 90 will equals to 0. We know that. Sorry, then my R will be under root of P square plus Q square, under root of P square plus Q square. Then my direction is also changed because of this alpha. Then my what will be my direction? We have the theta equals to tan inverse under root of Q sin alpha upon P plus Q sin alpha Q cos alpha. The put the value of alpha 90 degree. then q sine 90 degree p plus q cos 90 degree. The sine 90 degree is, which is 1, the cos 90 degree which is 0, then my tan inverse will be q upon p. Second case is if two forces p and q are equal and are acting at an angle alpha between them, then magnitude and direction resultant given by r equals to under root of p square plus q square plus 2pq cos alpha, which is if they are acting on a angle between alpha, but they both are what, they both are equal, then p equals to q. So put the q value as p, then p square plus 2p square plus 2p multiplied by p cos alpha, then my value will be 2p cos alpha by 2. Then the direction theta will be, put the value of q as p, then tan inverse p sin alpha upon p plus p cos alpha, then my after solution my value will my direction will be alpha by 2. So this is my law of parallelogram. The next is law of triangle of forces. It states that if three forces acting at a point be represented in magnitude and direction by three sides of triangle, take in order, they will be in equilibrium. My uh, if a point, if I have a point and there are three force of there are three forces are acting on this point, then my magnitude, my direction represented as as a sides of triangle in the as the three sides of my triangle. Okay. So next is Lami's theorem. It states that if three forces acting at a point are in equilibrium, each force will be proportional to the same, to the sine of angle between the other two forces. Each forces are each forces are proportional, like p upon sine beta equals to constant, q upon sine gamma equals to constant, and r upon sine alpha equals to constant. That means p upon sine beta equals to q upon sine gamma equals to r upon sine alpha. These three forces will be proportional to the sine angle between other two forces. Like if I am talking about this p force, then it other two force angle is beta. If we talk about this q force, then other force angle is gamma, other two force angle is gamma. And if we talk about this r, then other two force angle between is alpha. So p upon sine beta equals to q upon sine alpha equals to r upon sine, sorry, q upon sine gamma equals to r upon sine alpha. Now there are some units. What is system of units? There are three types of units. Okay. First, CGS. What is CGS? Centimeter gram seconds. The second, MKS. What is MKS? Meter kilogram seconds. Third, SI. What is SI? International system of units. So these are three types of units. The in the CGS, we in this CGS system, the length is expressed in centimeter, mass is in gram, and time is in second. Same as in MKS, length is expressed in meter, mass is kilogram, and time in second. In SI, it is called also as an international system of units. Okay. So in this system we expressed in a meter, mass in kilogram, and the times length in a meter, mass in kilogram, and time in seconds. The unit of forces of this system, Newton. In this system, the unit of force is Newton, represented by N. Newton is the force acting on a mass of 1 kilogram and producing an acceleration of 1 meter per second square. The relation between the Newton and dyne is obtained as 1 Newton equals to 1 kilogram mass multiplied by 1 meter per upon second square. Then 1 Newton will be 10 ki power 5 dyne. Okay. So these are some these are some conversation conversation between the kilonewton to newton, kilo to mega to giga. These are some representations. There are some trigonometric formula and expression which we have to know, just because of why we have to solve the triangles, we have to solve the parallelograms. So we know about the conversation between sine theta, what is sine theta, what is cos theta, what is tan theta, the formulas of sine theta, cos theta. There are some formulas of trigonometry which we have to know to solve these kind of problems of related to this law of parallelogram and law of triangles. So sine theta, what is sine cos tan in a 90-degree angle or in a right angle triangle? Okay, there are three types of thetas. First, sine theta. Second, cos theta. Third, tan theta. What is sine theta? AC divided by BC. What is AC and BC? AC is this side and BC is this side. Okay. Now, next is cos theta. AB base upon this BC. Okay. What is tan theta? This AC divided by this AB. That is my tan theta. Done. Now, the formula, next formula is sine A plus B, which is sine A cos B plus cos A sine B. Sine A minus B, sine A cos B minus cos A sine B. Cos A plus B, cos A cos B minus sine A sine B, and cos A minus B, cos A cos B plus sine A sine B. Tan A plus B equals to tan A plus tan B upon 1 minus tan A tan B. Tan A minus B equals to tan A minus tan B upon 1 plus tan A tan B. Sin 2A equals to 2 sin A cos A sin square theta plus cos square theta equals to 1. These are the basic formula which we have to remember all the time when we calculate, or when we know the when we determine the resultant force, when we determine the magnitude of resultant force, when we determine the direction of resultant force. So these are some formulas. Next are some differentiation and integrations formula which we have to know. The next is our first question, first problem. The problem says two forces of magnitude, which is 10 Newton and 8 Newton, are acting at a point. If the angle between the two forces is 60-degree, determine the magnitude and result. What we have to determine here, we have to determine magnitude and resultant force. So force 1 P equals to, we can say 10 Newton. Force 2 Q equals to 8 Newton. Angle between these forces is alpha. So what is my magnitude of resultant force formula? R equals to P square plus Q square plus 2PQ cos alpha. Put the value of P and Q and alpha in this formula, then my formula will be under root of 10 square plus 8 square plus 2 multiplied by 10 multiplied by 8 multiplied by cos 60 degree. The value of cos 60 is 1 by 2. Then R, my value of R resultant force, magnitude of resultant force will be 15.62 Newton. Then so here we have to determine the magnitude. We determine the magnitude as 15.62 Newton. Next, my problem says two equal forces are acting at a point with an angle 60 between them. If the resultant force is equal to 20 multiplied by under root of 3 Newton, find the magnitude of each force. Angle between the force is alpha equals to 60-degree. R equals to given 20 multiplied by under root 3. Let P is the magnitude of each force. Then R equals to 2P cos alpha by 2, which is 20 multiplied by root 3 equals to 2P multiplied by cos 60 by 2. Then my value will be P multiplied by under root 3. So what is if I have to calculate this P, I know the value of R, which is 20 multiplied by under root 3. Then my P value will be 20 Newton. The magnitude of each force will be 20 Newton. Next problem says the resultant of two forces when the acting at an angle of 60 degree is 40 newton. If the same forces are acting at a right angle, their resultant is under root of 136 newton. Determine the magnitude of two forces. So first case is resultant r1 equals to 40 newton, angle alpha equals to 60 degree. Second case r2 equals to what? 136 newton, and the alpha will be 93. There are two cases. We already studied these two cases, so put the formula of that two cases in this question. So first, for first case, r equals to under root of p square plus q square plus 2pq cos alpha. Put the value of r and p and q, sorry, r and cos alpha. The value will be 14 equals to under root of p square plus q square plus 2pq cos 60. Then my value will be 14. After solving this, my value will be 14 equals to r p square plus q square plus pq. uh, Squaring it, by squaring it, to remove this under root, then my value will be 196 equals to p square plus q square plus pq. For second case, my formula will be r equals to, my formula is r equals to p square plus q square. Then put the value of r. My value will be 1 under root of 136 equals to under root of p square plus q square. Squaring both sides to remove this is under root, then my value will be 136 equals to p square plus q. This is the first equation, this is the second. Now what we have to do, the simple thing, what, solve these two equations to find out the value of p and q. So subtracting equation 2 from equation 1, then we get 196 minus 136 equals to p square plus q square plus pq minus p square plus under bracket में p square plus q square. Then 196 minus 136 will be the 60. P square plus q square plus pq minus ka p square minus ka q square. The both values are cut from this because of this subtraction sign. Then my value only rest is pq. So 60 equals to pq. Multiplying the above equation by 2, we get 120 equals to 2pq. Adding the equation of 4 and second, adding this equation and second equation, then my value is 256 p square plus q square plus 2pq, or 16 square equals to please plus q ka whole square. Then my p value is 16 minus q. Put this p value in the equation, then my value is 60 equals to 16 minus q, we multiply by q. Then my value of q by the quadratic equation formula is 10 and 6. If first substituting the value of q in the equation, then my p value will be 6 or 10. So my two forces are 10 newton or 6 newton. This is my answer. Next question says two forces are acting at a point O shown in figure. Determine the resultant in the magnitude and the direction. These are my two forces. This is my alpha angle, which is given here 30 degree. P force is 50 degree, Q force is 100 degree. Now, first we have to find out the magnitude of resultant, which is we can calculate by the formula P square plus Q square plus 2pq cos alpha. Put the value of P, Q and alpha in this formula, then my R will be 145.46 Newton. Now we have to what, find out the direction of this resultant. Then formula is tan theta, theta equals to tan inverse q sin alpha upon p q, p plus q cos alpha. Then put these value q, p and alpha in this equation, then my theta will be 20.10 degree. Then my angle made by resultant with the x-axis is theta plus 15, which is 20.10 plus 15, which is 35.10 degree, which is my answer. Next question says the resultant of two concurrent forces is 1500 and angle between the forces 90 degree. The resultant makes of angle an angle 36 degree with the one of forces varying the magnitude of each force. So we have resultant which is 1500, We have angle between the forces, which is alpha, which is 90 degree. Angle made by resultant with the one force is theta equals to 36 degree. Let P and Q are the two forces. Using equation tan theta equals to what? Q sine alpha upon P plus Q sine cos alpha. Then my Q will be 0.726 P. Then my magnitude formula, which what is my magnitude formula, which is R equals to P square plus Q square plus under root 2PQ cos alpha ka whole under root. Then my I have to remove this under root by squaring this side. Then R square equals to P square plus Q square plus 2PQ cos alpha. Put the value of R, put the value of Q, put the value of alpha in this equation. Then my P value will be 1213.86 Newton. Substituting this value in this Q of equation, then my Q will be 881.26 Newton. So this is the simplest form I can say, which we which we can simplify the resultant, which we can simplify the resultant's magnitude and direction by these sum formulas. I hope you don't have any query in this session, but if you have, then please mention in a comment box. I'll resolve it. This session is powered by Digital Version 2.0 Jayati Vidyapeeth Women's University. Thank you.